Hello. Today's conversation is with Ross Taylor. Ross was previously an LLM lead at Meta AI, heading the reasoning team. Before that, he worked on LLM agents, Galactica, and other great projects at Meta. He was a co-founder of Papers with Code, which was acquired by Meta, and I consider an early Hugging Face competitor. Before that, he has a round of engineering and technical experience in quant, sports betting, finance, government. And he's currently working on a new startup that we don't know what it is. But this is a wonderful conversation on some of the early breakthroughs of language models, papers with code, evaluation, Galactica, the controversy, and the actual underlying interesting parts of that model and how to build demos, reasoning with language models, RLHF, how to scale RLHF rather than fine tuning, how to build a successful RLHF team, how to focus on data, what language model reasoning actually means, and many other topics. So I hope you enjoy this conversation with Ross Taylor. Hello. Today we're here with Ross. This is a really exciting one. I've been trying to get Ross on the show for a while. Ross has done a lot of interesting, like the path to where you ended up with working on state-of-the-art Llama things at Meta is also interesting to me. So we're going to start with some of that, but then there are a few people that know more about reasoning and some of the RLHF stuff that I'm very interested in. We won't cover the secretive new startup that I also don't know what it is, but that's how it goes these days. I'm sure it'll be great. So welcome to the show.
Thanks for having me.
Yeah, so I wanted to start with Papers with Code. For people that don't know, Papers with Code is one of these platforms. I never was a heavy user of it, but kind of collating papers, people could upvote them, popular papers, attaching code and data set and evaluations to papers, which is great. But it's like sort of ahead of its time. It fits into a lot of these open ecosystem things. So I'm kind of curious, like how you ended up there and why you all started this startup that ended up building this thing that got acquired by Meta.
Yeah, that was a weird one. So this was like back in 2018. So I was at an incubator. I just quit my previous job and I was like, okay, I want to do a startup. And I met Rob, my co-founder, who also kind of came along with me with the journey. And it was weird. We both came from different backgrounds. I was more from I'd say like a sports betting, quant finance, like kind of background, which is a whole another episode, I guess. And Rob was kind of like in various startups, like applying ML to things like hate speech detection, that kind of stuff. And the cool thing was we kind of both like resonated on similar kinds of problems within like the ML space, even though we were kind of different domains. So we spent a lot of time like doing various experiments, like trying to find like new kinds of ML tools, like thinking of these like kind of stupid questions, like, what is the Git equivalent for ML, that kind of stuff. And the thing that surprised us was like the thing it kicked off. We kind of hacked around with this like little website to solve this really basic problem. Like, okay, I'm trying to reproduce this paper, but I can't find the code. And that was the thing that really like blew up to our expectation, which is kind of weird because we kind of thought it was like fairly trivial.
What year was this? I try to put these things in years.
2018. Yeah,
this makes sense. I think this was like, this is like what I was doing starting DeepRL then, but DeepRL was so hot, which is like the worst evaluation has ever been probably for ML. Like people complain about it today, but like DeepRL evaluation was like every single person was just lying to make themselves look better.
Yeah. And the interesting thing now is like, I guess like the open ecosystem now shifted to focus more on things like weights as a central artifact rather than code. I think there's an interesting debate there. Like, would it be more useful to have like, I don't know, the Llama 3, 8 billion model weights or the Llama 3 model code, right? I think there's still different interesting debates about
I think the code would be more useful. I mean, we see this, like OpenAI released their rules-based reward models, and there's code, but it's like code washing because it's like just a bunch of people just release like eval code now, and it's like that's a whole nother tier is like actual training code versus eval code.
But yeah, I guess I should skip ahead. So essentially, Papers of Code was the thing that didn't die for us. We always thought we were going to make something else, and like Papers of Code was like a marketing thing. But eventually we were like, okay, our users are telling us like this is what you should work on. And we kind of expanded away, from that just very simple use case of like finding code to like, indexing various artifacts in ML. So another big problem was like, okay, what's the state of the art on something like ImageNet or these different benchmarks? There just wasn't a central place to find information. So, if my journey was like, okay, I'm trying to do this task in the company or I'm a researcher, like, what's the best method for that task, right? So we had this like quite good Christmas, me and Robert. We just like hacked for the whole month, just like indexing essentially every leaderboard we could, like papers. It was pretty mental. I didn't want to do like any annotation again after that, but and that like really took it to the next tier, and that's when things really started to blow up. So over
Because
the
this is
journey,
like the first round of leaderboards. Because now it's really popular
yeah,
with Hugging Face again. And I was like,
yeah.
is that
It goes
just
in
because it
different
became like a
directions.
meta thing and it's just kind of a thing that existed? You're like the first leaderboard company in a way, which I don't think many people think about
Yeah,
today.
which is weird. Yeah, and the interesting thing about us was like it was like really nice. We never had to do any marketing because everything was like for organic traffic. So if you just typed in like, okay, like state of the art ImageNet, we just come to the top because we're kind of the most useful site. So that was like really a source of our growth, and we kind of grew to like million MAU like fairly quickly in a couple of years. And Meta, we were kind of in touch with the PyTorch folks at the time who we really liked, like Sumith, Joe, like those kind of folks. And obviously they had a shared like kind of interest in promoting like the open source ecosystem. This is back 2018, 19. And well, it was like a tough decision, and we were just like, well, we really like working with these people. We want to work more closely, and that kind of got us into Meta. And then, I guess within Meta, we kind of originally started, continued to develop the platform. But I think the big shift for us was like, even then, we kind of saw that like things were moving to this world where like compute was like the kind of the currency, and like if you want to be well positioned 5 years time, you're going to have to like build these like large systems. And even for our own platform, we had lots of ML in the background, and we kind of saw we were using like fewer and fewer models to do more and more tasks. So that kind of shifted us into research, into Galactica, and then eventually Llama and that kind of stuff, which is kind of a weird shift because we were kind of product people. We ended up doing like hardcore research, but I guess it was natural to us that we're kind of placed within this kind of research org with these like amazing people, lots of resources. It was just the best use of our time to then kind of
Do you
shift.
think like there should have been more integration between Hugging Face and Papers with Code? This is one that I never
Yeah.
thought like it's just kind of how things happen, but it would be wonderful if it had happened.
The backstory is like we kind of saw them as competitors, to be honest, because like we actually had the same vision originally. Like we were going to do model hosting, that kind of stuff, but we never got into it because actually the frictions at Meta were like leadership was not on board with that as a goal. Because for their point of view, it's like, okay, if we host these things and maybe that exposes Facebook to some like legal risk or something like that. It just wasn't in the interest of the company.
This is a classic story of tech, really.
Yeah, pretty much.
Like,
Yeah.
they can't take the risk. They can't expose themselves.
Yeah.
Especially
Whereas
at that time.
if you're a startup and it's your number one priority, then yeah, your attitude and risk is different. But I think it was a blessing in disguise for us because like clearly the wave was going to be like large language models. Like obviously we saw that incredibly early, and our mission was fundamentally not actually infrastructure, but something more close to like how do you, organize information, almost kind of like a Googly type of mission. And also we were focused on ML, but broadly thinking about science more broadly, like how do we reduce frictions for like finding out new advances and just like lots of these like kind of I guess like small tasks that when added up like lead to lots of like progress in science.
I should have probably looked this up. Did you have another scientific background? Because I saw all the quant these other jobs before. Did you have like a hard science background, or what about Rob's? Was it Stoichich?
Stoinich, my co-founder, he was like from a bio background, so he's actually
that makes sense.
Well, he was also computer science. Like he was one of the original like developers of Wikipedia, so he has his own like crazy story.
God, for me, yesterday I was talking to somebody that was one of the original archive moderators. So we're digging all these things.
There you go. Yeah. And so that's interesting because we both had this background, I was saying, like building these useful public utilities. I think Papers with Code is one of those things which you can kind of forget, but if it went away one day, everyone would go crazy. But for me, my background was actually more kind of statistics, econometrics. So I was actually weird. My first job was actually in the government, which I kind of hated. But I did a master's degree, which I thought was going to be like economics, but the thing I really loved was actually like time series and statistics. So did all this kind of research on state-space models before it was kind of cool, I guess.
Yeah.
And then that got me into kind of sports betting and stuff. And then eventually, we were kind of using more and more deep learning. I guess that's how I got into it. So fairly non-linear path, but
yeah. Well, back to what you were saying on the scientific stuff. I think the Galactica story has many angles. You're the lead on this. I think if people go look at the paper, it's a very interesting paper. Like you cite Galileo in the first sentence and stuff like this, and it really has a lot of. I see it as having a lot of early like modern language model features and quirks. It's something that people don't remember for being that. I think that I mean, I'm very on the record saying the backlash was overblown. I think that was before there was clear habits and community norms around what language model demos should look like. So like it was kind of in that teething phase, but like, what was the actual goal that you wanted? Like you mentioned organizing the world's information. Like, what was the goal, and how close do you think the model came to accomplishing it?
Yeah, so I think there's like several different things at once. So there were like immediate product integrations we had in mind. So we actually had an agreement at the time with Overleaf to kind of like a bit like, you know, Copilot for GitHub. We'd have like a kind of a really good like LaTeX model in Overleaf, and whenever you wanted to like include a citation, you could just prompt it and have a citation. But then more broadly, we're like, we imagine the future would be like, you know, instead of us like manually, I mean, we had automation, but instead of us like trying to, you know, use these, like I would say, like more classical software techniques to extract information, we saw the future is like, okay, if you wanted to learn about DPO, you'd just be prompting like a language model to find out about that thing. Or, you know, if you wanted to say, okay, what's the, you know, the state of the art on, I don't know, like SWE agent or something like that. Like you just prompt the model and it would like collect information and do that. So
this is something that language models are so bad at. One of my challenge questions,
yeah.
I've been doing this for 6 to 12 months, is I ask models about DPO, and none of the models without internet access have yet done it right. You would think that it would start to kick in, but I don't say like, what is DPO? It's like, what is DPO for language model fine tuning? And they still just make up nonsense.
Yeah, which is actually a whole interesting debate about like, if you want to solve something like LLM creativity, you want to be on the frontier, and actually the frontier kind of knowledge is actually where you have the most scarcity in terms of tokens, but that's a whole different debate. But yeah, just to finish that thought, like we saw fairly early that we thought like, bear in mind, like we were developing Galactica for like the whole like Web3 boom and stuff, and we were kind of in this weird state where we're like, all that Twitter is talking about Web3, but clearly like, you know, generative AI is going to be the thing, which is like, you know, before that was a term, was going to be the thing that powered the next generation of the web. So I guess that was our overriding goal. Now, in terms of the actual like launch, I think there's two aspects. Like you said, the paper, which, you know, I think our team, you know, we're a small team of like 7-8 people. It was so much fun. We were so like having so much like fun and consuming these like whole new ideas at the time, like tool use, you know, these kind of like internal reasoning tokens, like how do language models cite? You know, can we train for multiple epochs? Like what
was it a citing token? Did you have a special token for citations?
Yeah. So we had like a start citation token, and we actually used two methods. The first was like we'd put a title of the paper within the citation tags, and the other one would we have like an alphanumeric ID. And the ironic thing is it actually worked really well, but in the demo interface, it kind of had this tendency to hallucinate, or I think the phrase is like hallucitate is like the special term. Now, the interesting backstory in that was like the model was actually really good, but for the demo, we turned the temperature up to 0.7 or something, so the text generation was good. So it's actually like a product of us like going too fast on like the demo, and then so it's kind of something that people thought was broken, but actually wasn't. But that's like I guess like an alternative fork. So there's a paper which is like this really cool, you know, thing, and then there was a demo which I would say is like it was motivated by the realities where we were at the time. So this was pre-ChatGPT, and even within a big company like Meta, like it wasn't a priority to do LLMs at all. So from our mind, like our objective was like to win. Like we're kind of deluded, but you know, a team of 7 people, we're like.
I mean, this is how you have to operate if you want to be at the cutting edge. Like that's how great teams operate.
Yeah, so there's like 2 objectives you could have had. The first is like you think actually second move advantage is good. So you wait for like OpenAI to do something, and then you come in and maybe do it an open way, right? And that's the one that actually worked for Llama and stuff, right? So Llama wasn't, you know, state of the art in any sense.
I mean, I've been doing this. Like I say that I don't like all of OpenAI and Gemini and stuff. Like, don't really have that much interest in at least like 6 months ago, especially. They don't need to hire me because they know everything. But now I'm like doing more interesting analysis where I'd be hired in a different role. But it's like in the open, I'm like the person people look at. I'm like, you don't understand. Like I'm 6 to 12 months behind everyone in the close.
But to be clear, it's a really important role because this is how, you know, everyone should have a stake in the future, and that's what the open kind of ecosystem does. But like our objective was like we didn't want to be second mover, we were going to be first, and we're kind of deluded because, you know, we're 8 people. You know, our competitors, maybe OpenAI, had like 200 people, and their whole bread and butter was language models. But we're like, you know, how do we move as fast as possible? And in our mind, it's like, okay, a demo would be premature, but it would be a way to get like lots of prompts and information quickly, like understand what people are doing. And essentially, the calculus we took was like we knew like probably the community wasn't ready, especially from like, you know, Meta with all the branding at the time. But we were like, this is like a way where, you know, maybe we could get lots of information really fast and, you know, really catch up, you know, with our position. And obviously, like history says,
like you kind of did that. I think Meta probably got the like an injection of language model reality from that. It's kind of like the Gemini backlash. Like I think the Gemini backlash, while is obviously a stupid execution, was potentially a good like forcing function for Google's like structure of their Gemini org to like really move everything into the same, like safety is in the same team now. and they can't do all these things. And that made them be structured more like a serious language modeling org and less like Google, I think, which people don't want to hear.
I mean, for us, I think it was just a risk, and it was like we probably took a lot more risk than we should have done. But we just thought, yeah, obviously this is going to be huge. LLM is going to power like the next internet. Let's take a risk. And if we ran the universe like several times over, it would have stuck in some of them. But it just like the criticism, which was obviously like overblown, but it just like reached that point where things had to change. And then there's I think the story of the demo coming down, which I'm not sure I'm at liberty to talk to, but I think that's one of the things which if people knew the true reasons, they'd be like, what the fuck? But they have to find out if back channels what actually happened. So, but
I mean, this is why now like any company that makes a demo has block lists where there's certain words that if they're in the prompt of the generation, you get a really, really stupid response. Even if it's like an open model, you just put like a little filter that's like, you can't say the most obviously bad words. And I get it.
We actually did that, and that was actually backlash as well. Because like if you get like, I can't remember if it's like true positives or false negatives, but if you do that too much, you actually exclude some words which aren't actually offensive, right? And then you also offend people. So it's like it's not a win-win situation. But I think, if I have to look back at it now, it's like I think with any new technology, like it's never like absolutely better than what came before it. So obviously with LLMs, the relative comparison is like search, right? So if you're going towards search and information retrieval, you're kind of prioritizing factuality as opposed to creativity, right? And the fundamental trade-off of LLMs is saying, I can trade off some amount of like factuality or quote unquote closeness to like the corpus for some like synthesis and creativity. I don't think like, in a sense, if we had a better model, I don't think it would have helped things at all. You could say maybe if we had like RLHF at that stage, would it have helped? Even then, I'm not too sure, because I think, especially coming out of Meta with like the kind of like, at the time, I think Meta has like a really good reputation now. People appreciate the open work they're doing. But at the time, like things like Cambridge Analytica and stuff was all kind of overhanging things a bit. So I think it was never kind of the LLM like revolution was never going to just like happen at Meta in my opinion. It was always going to happen from a startup that had maybe a bit less like reputational baggage. But I think it's pretty cool now that people see like because FAIR always had like a really good like commitment to open science. So I think it's good now that they're getting the credit for that, which is cool.
Yeah. Okay. I have two technical things on Galactica that I find really interesting. One is from Luca Soldani at AI2. They said that you mentioned the Galactica log probabilities when producing were proportional to how far in the citation graph the current paper was to the cited paper. Do you have any more interesting comments on like the latent space of like how Galactica actually worked? Because that is like cracking the most important question of a language model for science, is like actually building a better a latent representation of how the scientific information is organized.
So there was like a couple of things to that. So the first thing is we saw like, definitely with scale, we have like this really nice graph that kind of shows like, as we scaled the model, like the distribution of citations became closer and closer to the actual, which is what you'd expect. Because, for our main worry with doing this was that, because, we were thinking about deploying an overleaf, we didn't just want to prioritize the most cited documents so the rich get richer kind of thing.
Yeah, Google Scholar already does that. Were you re-indexing all the papers rather than building off like the Scholar graph or something?
I think we're building off existing ones, like using things like Crossref, that kind of stuff. But there were a lot of gaps as well. So that was really cool. And the weird thing is we saw like weird biases in the model. So like sometimes if the model didn't know, it would just like cites like a review paper, which is found really weird emergent behavior. So it's almost like it's saying like, I don't know a specific example, so I'll just give you like a general thing. And
this is very grad student behavior. It's probably in the data.
I think the thing that surprised me the most was actually so with Galactica in a weird way, it was multimodal. So we kind of trained on like these kind of like things like Smiles formulas, protein sequences. And the thing that really surprised me was like we had, there were like tasks which we didn't explicitly optimized for, converting, for example, like let's say like a Smiles formula to like IUPAC name of the chemical. And if you actually looked at the attention as it was like kind of predicting, like if it would say something like amino, you could actually see in the graph it was explicitly attending to like the portion of like the graph which was like the amino like bit to build a sequence. And we're like, which I found like both amazing because we didn't, kind of learn that explicitly. That's the beauty of self-supervised learning. But I also find it like highly ironic because like some of the criticism of Galactica was like, it's like ungrounded. I'm like, how grounded is this? It's like literally attending to like the underlying chemical structure when you say amino. So there's stuff like that, which is kind of cool. And then the other thing was like, if you kind of prompted for like things like, because we trained on stuff like UniProt, if you prompted for things like the protein sequences, and then we're like, okay, what is the function of this protein? It would then like come out with natural language and actually like be pretty good at that. So that kind of stuff.
That's awesome.
Thing for me.
There's another prompting thing that I had note of, which is like if you asked it to do kind of open-ended generation tasks, like the models are still out there, people can spin them up and do demos on their own. But if you ask it something that people think of ChatGPT, like write me a poem about a sad goldfish, like it wouldn't work unless you put it in like the header format, like it was Markdown, or like you like prompted it like it was LaTeX or something, and then it would actually do a great job.
I think the funny thing was in the demo, like although people were like being malicious with like some stupid prompts, like I did enjoy like some of the creative ones. It's like, someone was like, okay, write me a theorem on finding like a girlfriend or something like that, and it was just like some of the most like hilarious like output I've ever seen, and also some amazing sci-fi. And but then I think some people took it too far, but whatever. It was like I guess it was like a traumatizing experience for me at the time, but I guess with the benefit of hindsight, it was also it was fun in some senses. I guess.
Yeah, it makes you understand the bigger context of the work much faster than you would otherwise, which you now get the benefit of.
And it was actually crazy at the time. Like so many people were using it. So even then you could see that like in a weird way, although like, it wasn't a product, you could see that this was the way a lot of like, I guess systems were going to be designed. I think the interesting thing was like how the actual form factor in the end was like a chat interface. With ChatGPT being the winning like UX, and I think it's like well known now, but I think that was actually a big part of the story. Like in a weird way, I mean, there's a debate on whether RLHF is actually a capability advance or not, or if it's like a purely alignments. But a big part of the story why it won actually was more the kind of UX of how you interface with a language model, rather than the actual capabilities. But I think it's obviously not monocausal at the same time. There are several factors.
Yeah, the kind of last thing on this that you mentioned and in some of our emails is like language models and creativity and making discoveries. Like, what do you mean by that? Is that kind of like, you had mentioned that you worked on agent-like things at Meta, which I don't know if there was as many outputs from. And agents are largely something that I don't have too much comment on. I'm kind of taking the approach of wait and see what we actually get, because there are a lot of tractable approaches that I think will be reasonable. Like people use language models for basic formatting. They're not quite a search, but it's for code and all of this, but it's easy to see like if they have a little bit more feedback for things like writing a paper. It's like, find me a citation for blank and justify your answer. Like that step is something that I think will come. I don't know how expensive it will be to run, but is that what you mean when you think about making discoveries? Is it more autonomous? Is it a grander vision? Anything like that?
I think it's more just like the killer use case LLMs right now is like information synthesis. Like, I use ChatGPT or Claude more than Google because it just kind of combines information in a better way and sometimes like generalizes to things it's never seen before. But a really cool thing would be like, can it answer like a question which is like more like out of distribution that we don't like kind of see in the training data, right? So an experiment I've never done because I didn't have the compute would be like, imagine if you could train a language model on like all documents up to like 1905, which is like the year when like Einstein had his like, miraculous year of all these papers, right? Like with that model, which is trained up to like 1905, could you prompt the model to come up with like the photoelectric effects, like the, special relativity, this kind of stuff? And what would it take to like prompt it, right? Because presumably like all major discoveries is never like out in the blue, like you're standing on the shoulders of giants, but there's a lot of like quote unquote thought and iteration you have to do to get to those great discoveries, right? So that's kind of the setup. But I think the problem is like by its very nature, if you're doing creativity, like what's the benchmark you should use? And I think there's actually, maybe this is like a digression, but I'd say a lot of the problem I have right now is like we're in a situation where we've almost solved like a benchmark like math, which is like a very hard benchmark in my opinion, at least a level 5 one. But I don't think we've really cracked like something like reasoning. But I think it's like a whole different question about how you even evaluate these kind of like frontier tasks. but yeah, hopefully that gives a flavor of the kind of like.
Yeah, we could
Case.
go into this reasoning
Yeah,
conversation. I think reasoning in RLHF will take up however much time we want to keep talking. Like,
yeah,
I guess we could start with the basic thing. It's like, what do you think like people that are using language models think reasoning means, and what is the way that like you would interpret what you're trying to do in or improving reasoning of a language model?
yeah. So there's a lot of controversy on this on Twitter or X, and I think people are talking past each other because I think sometimes people mean different things by reasoning. Is something like, even at like a very granular level, is like legal reasoning fundamentally the same as mathematical reasoning or like common sense reasoning. I guess like my very like basic definition is like reasoning is the process of drawing conclusions based on a body of observations, or in the case of deductive reasoning, like basic premises. And
So math is like a subset of what you think about.
yeah. And then I guess the bigger circle is like a broader thing of, outcome directed behavior. Like, okay, I have an idea of an outcome I want to achieve. Like, what's the best like path to get there, right? So yeah, I guess that's the definition. And then in the LLM space, I think this broadly equates to like the technical problem about how to use compute in order to get from like, your question to your answer, right? So in the old days, you just prompt the language model directly, right? You just put in the GSMA question, put in answer colon, and be like A, B, C, D. So you're relying on like the forward pass.
Yeah, like the FLAN data is really weird. Like that's a popular one that people use to train on this stuff.
Yeah, and then obviously chain of thought, these kind of ideas, scratch pads, like we work with Galactica, kind of then using like the kind of context window to do the intermediate computation. And then the more recent, although to be honest, it's actually quite an old idea, is like, okay, you have chain of thought, but how do you better learn like the kind of internal reasoning tokens that get you to your answer? So things like, quiet star and stuff like variants of this idea.
Yeah, because Claude now shows you I'm thinking, and in Claude system prompt is like, take X tokens to think about this, and it's like, we're thinking about trying this stuff, and it's all so hard. I think we like.
It's a question of like how you learn those tokens. I mean, for us, we did the original like kind of work thing we did was like just like supervised learning. Essentially, we just annotated some examples and let the model kind of generalize to know that it's trying to do the thinking in between the tokens. But I think there's more sophisticated ways you could do it nowadays. I guess there's a final debate about I think this analogy is like quite used that like language models think out loud. But I actually don't like this analogy at all. Because I think thinking out loud makes you think that actually there's something wrong about like, this kind of thinking in token space ideas. But it's not actually clear to me that the alternative are like these old like adaptive computation ideas are any better actually.
What do you mean by adaptive computation? Because I mostly think of, you're saying like thinking out loud being like chain of thought or like generating its own explanation before it gets to an answer. What would adaptive be?
So there's a paper by Alex Graves who's like done all these amazing like papers like 10 years ago. They're like very like had a lot of foresight. So he did like the neural Turing machine like papers, this kind of stuff. Adaptive compute is the idea that essentially like instead of like having fixed compute between your input and your output, you can kind of extend the forward pass to do things better like arithmetic where you have to maintain states, that kind of stuff. And I think when chain of thought came out, there was an impression that kind of chain of thought is a bit of a hack because you're kind of thinking in token space when you should be just kind of like having a way to like make the kind of forward pass dynamic. Universal transformer is another like kind of variant of this idea. But I think there needs to be more empirics on like which approach is actually better to maintain state. And I used to be more in favor of thinking, okay, chain of thought's more of a hack, but now I actually think it's probably.
What do you mean by state? Like the state of the state of the problem in that sense?
Yeah. So imagine like you're doing a GSMA case. You're like, okay, John originally had 100 apples, then Jane gives him 5 apples. He has 105, right? And then he gives 20 away to like Susan or something, and he's left with this, right? So imagine that you're just prompting the language model directly for the answer. You're expecting the language model in that forward pass to maintain the state in like a latent space, whereas the way chain of thought does it is in token space. So you essentially output the intermediate, and at least I guess one of the problems with reasoning is that actually people have no idea how like humans actually mechanistically like kind of reason. But if you at least like think about how you'd solve like a GSMA problem in your head, to me, it seems a lot more close to something like chain of thought, and it does adaptive computation. Like it's just,
Especially when you look at the architecture, like attention mechanisms, like Transformer is really good at copying. So if you like keep
yeah,
feeding in the recent information, like it can it like copies that in some way. So I think chain of thought
yeah,
and all of these things. I mean, they're only growing in my mind. I think like the chain of thought's growing, all this quiet star, which I haven't read the papers on, but I know all the rumors, and there's all of the, it's like self explanations and stuff, and all these special, like
yeah,
the Llama 3 paper has all these special tokens. I don't know what all of them do, but it's going in that direction where it's stored. The state is stored in context and in special formatting tokens if it needs to
yeah.
be.
So the other big picture thing is like the internet, you're only seeing like output context. So imagine like on Stack Exchange, right? If it's a good answer, chances are they haven't just like responded and gone left to right from beginning to end. They've probably done, maybe they've looked something up, or maybe they've done some like, back of the envelope calculation, either explicitly or in their head, right? And the internet is like missing those tokens essentially. Now, this isn't a problem for some things because the models, to kind of learn how to construct it. And I think the effort now is to kind of make these kind of artificial latents, through like RL or otherwise. But I think that's actually like a much bigger question, which is more than just like reasoning. It's like, in the end, as the models become more capable, I think we'll be talking more about like we would like them to be more human in the way they kind of answer questions. And that's not just a question about reasoning. It's also about, okay, maybe I want them to have some empathy in this like situation, stuff like that. So my prediction is that this becomes a bigger deal in the next few years, about like caring more deeply about the computation these models do to reach a conclusion, and that will be the essence of alignment in my mind. But maybe that's like a
yeah. Okay, I have a long list of specifics on this. I wanted to start. First one is like process reward models. I think the canonical papers, let's verify step by step. My whole gripe is like, I guess that it's hard to create the data, so that's why they don't exist in the open. But I'm guessing you could label data with GPT and just ask for feedback on each step, and just use some LLM as a judge to get reasonable step-by-step labels on process rewards. Because I think that like they are worth exploring, but I don't know if they have dead ends because there's so little. Like there's some research from Meta. I think like Alex Harvrilla did a couple internship projects which related to them, and he's good. But there's such a lack of signal. And is there any like, should this be something that people work on more, or is it too complicated and like there's simpler things to do?
So I might be wrong on this, but our take was actually, what's the problem you're trying to solve? So for us, there are like two things. Like, our big kind of direction was like, okay, we want to integrate kind of outcomes into reasoning because like, next token prediction is misaligned, right? So the two ways are either through like something like PPO or inference time search. And in both those cases, you want like a good reward model, like value network, right? And the way we saw it is like, if you want to like, quote unquote, process-based reward, and for us, we actually ignore that and say, well, actually, no, we just want feedback on each step, right? So we were definitely exploring more, ideas on the lines of like Monte Carlo policy evaluation, where the key problem is like, how do you get a value network? And I think this is maybe a separate topic, but I think it's unappreciated that, something like, MCTS as an example, right? So I think in the public imagination, it's like this, inference time search technique, but actually the real magic of MCTS is it gives you a value network kind of for free, essentially. I mean, that's why it was introduced in Go, right? Because they couldn't come up with good heuristics. So if you have something like math where like the answer, right? And then the question is like, how do you assign step-by-step feedback? Then it doesn't have to be MCTS, but something where you essentially backprop, essentially the outcome to these individual steps. That's probably a way to get, quote unquote, synthetic process reward. Now, I should stress they're actually different things, process reward and kind of like these kind of Monte Carlo policy evaluation based data sets. I think Alex Harvrilla was doing something along these lines, but I guess that's the approach I'd take there.
Yeah, I mean, when Q-Star came out, or rumored, that's something, it's related to what I was thinking. It's like, you could do this, like, instead of chain of thought, there's this idea of tree of thought, which is you can kind of swap in reasoning steps. And then somehow, if you just, like, get labels on all of these reasoning steps, you're doing search over a reasoning space, which I expect to work. It just takes a lot of, I think a large part of the, like, open alignment community right now is under appreciating data sets, where there's a lot of focus on methods, but we don't even have the data sets to use the methods. So, like, why are we coming up with 7 DPO variants? It just like is not like, I understand academic incentives, but if you are not an academic, you don't need to be doing that.
It's an interesting question because like I guess the impression of ChatGPT was there was a lot of focus on, I would say, like human annotations, right? And then in a way that's a barrier to entry for the open community because, you know, if like these big firms are paying like millions, right, it's not something they're going to open source or that, you know, an individual researcher is going to pay for, right? But then see, you've had the rise of things like, you know, constitutional AI, these other approaches and stuff, which I believe are like comparable to human data sets anyway, right? So is that a good thing for the open community? I guess
I think it is, but there's multiple sides that human preference data is a leg that is hard to remove. I think this is one of my. This was the later question: is like, can we actually do LLM as a judge for human preference data fully? And I don't. That I think is the critical step that we don't have an answer for, where everything else in the modern RLHF stack is becoming much more reproducible in the open. I think I have a question on like synthetic versus human SFT because there's now like the Llama 3. I don't know if it's in the paper, but Thomas on Latent Space said like we just use generations from the model because they're better for humans on a lot of SFT tasks. Apple had a quote in their foundation model saying the same thing. So like I'm like, okay, let's redo all of our generations for our SFT data set with either the latest GPT-4 or Llama 405B. Like, why are we using GPT-4 from March of 2023? Like that was not as good as reasoning. So we have headroom there on synthetic data. We have prompts that we could reuse, but we don't have like these preference data sets that people use, like ultra feedback and stuff, are not big enough. And I think they're not in the same style that a lot of labs are doing, this preference tuning, where it's like this on policy generation thing, which is how you work with, like, we tried to work with Scale at Hugging Face and do this, where we had like our own SFT models, we were getting data from Scale, we were labeling it every week, and we were trying to retrain the models, and we weren't getting signal. This was like last July and August, so we just didn't really know what we were doing. But I suspect that this is what people in the open should be trying to do, is like generate a ton of generations from good SFT models, label it. And it just seemed like I was just like, it's just a light bulb moment for me recently. It's like, this is what we have to do, but no one has done it. And why, like, what are people doing other things for? Because I mean, that sounds like the Llama loop, but you have a bit more, Llama has more money to spend on fancy things.
Yeah. I think it's definitely underappreciated to the point you made about like, if you sample, you get better kind of answers than a human. Obviously, like you mentioned, like Tom made this point early on in the Llama project, but like, you'd be surprised how that extends to reasoning as well. So like even the Galactica model, which is now like, you know, ancient model, like kind of Bronze Age like model, you know, the pass at like 100 GSM-8K was like 98%. And it's like absolutely crazy to me that even now people are still using GSM-8K as a benchmark. In my mind, like the model was already sold in like 2021.
Was Galactica trained on the GSM-8K training set?
Not that I'm aware of, no. I think there might have been some GSM-8K-like traces.
That makes it even more impressive, because a lot of people get high number. So a lot of the benchmarks, I don't know which ones is which, but a lot of them have training sets that accompany the test sets, and then it's like far more impressive for a model to get a high evaluation score without training on the training set.
I think it's a more subtle point, because the zero shot, I think, was something like 48% or something, right? But the pass 100 is like 98%. So the insight there is like, the model has a knowledge of how to answer something correctly. It's just not reliable, right? Which then tells you that, okay, that's why you need to invest in like kind of reward models, everything we talked about, like process reward, outcome reward, that kind of stuff. But I think the same applies to like the general RLHF platform too, right? Like if you have to, you know, ask like, you know, write me, I don't know, a poem in the style of, I don't know, Bertrand Russell, like, or something, but also mix in Snoop Dogg. I couldn't do that, right? But the model has knowledge of how to do that, right? So why wouldn't you sample the model? So then all this is a long way of saying, like, maybe you can put more weight on like having a good verifier as opposed to a good generator. And there's like a big debate there. And again, just to stress, I think now with like Llama 3, the 405B model being out, I guess it's going to be good for the community now that hopefully, if they can like run the inference for it, can kind of use that for generating, like you said, some of this preference data synthetically. And I'd imagine the quality will be good enough if it's done the right way. So
yeah, I think it should be doable. I'm like, there's a fundamental question of like, what do we think that the human preference data is doing? The LLM as a judge is not. Like, there's got to be something. I'm kind of thinking that if we have like this, like ultra feedback is the canonical example of GPT-4 labeled preference data. no, like I haven't seen the example where somebody then takes it to Claude and is like, is this a correct preference sample, and throws out everything that is a no. Like, is that going to make it too saturated, or is that going to actually make it better, or is the noise that the humans provide like of a different distribution that makes the human preference data better? This is one of the, I don't have a lot of signal into this, but I would love to know, because I would guess that Meta would eliminate the $10 million plus estimated human preference data spend if they could. Like, Meta is a reasonable company.
I don't know. I mean, what was I going to say? So for like, I think something that surprised me so I was originally skeptical, at least on the reasoning side, of like LLMs kind of evaluating their own homework, I suppose. I mean, I thought eventually that they would have that capability, but I wasn't sure how fast. But then the interesting thing we saw was like we'd do experiments where we'd have like a Llama 2 model that we'd sample generations for like an ORM model, but then we train the kind of reward model on like different base models, and then what you saw is like, okay, the better base model you have, the better the kind of results you have, the better it is at evaluating, right? And you could see this very like clear pattern as like the base model that you use for the reward model improving, like it's the ORM performance is getting a lot better. So that tells you that the knowledge is not in the ORM samples that you've kind of fine-tuned the base model on. It's actually latent within the model itself. And the pattern was so clear in the scaling. I was like, okay, eventually these kind of self-verified judgments are going to work. It's just a question of, I guess, what order of magnitude for certain problems. Yeah.
And density, like model capabilities are getting more dense, which helps us as well. Like smaller model, like it's getting, there's all these experiments with better data. You get a better model with X percentage reduction, which is kind of off topic. I think to double down on what you said, this is one of the things that I also debate is what makes a good model for downstream fine tuning. I think this is for a base model to fine tuning, a base model to reward model. I think the Llama 3 report, they trained the reward models directly on the base and not on the SFT model. That could be like a reading interpretation error. The Apple report mentioned that they don't just use their evaluation suite for SFT models, but they do some like best event evaluation with a reward model to see what is ready for RL. And I think especially in the open, if you want the people to adapt your base model, there's a big gain to making it easy to fine tune, because like Llama's been pretty good. Like Llama 2 especially was really good for fine tuning, but there's been base models that come out that just don't really work for fine tuning, partially due to bugs and partially due to the state of the deep learning optimization. Is this something that like you have any insight into, or is it kind of just, I think it might just be good model good and just be kind of boring at the end of the day?
Yeah, I don't think I have enough insight into it to say, but I think it's definitely something that's been like undervalued, I would say. I think the view of like I guess a lot of open model providers is you get the model out, get good open LLM leaderboard results, and it's kind of mission accomplished. But then to be honest, the real evaluation is 2 days time, where you get these kind of like anon accounts on like X saying, I'm fine tuning this Llama model, it's not working, and then you see like a pattern and it's like okay, something's wrong.
It's always a chat template thing. It's a lot of it is a chat template thing, but those do get ironed out eventually. Because there's this whole idea of annealing and like staging of pre-training. I can't tell if it is boosting the capabilities at the cost, like the current capabilities at the cost of later capabilities. I think in a few years this will all shuffle out, and it's just how we do evaluation in stages. So you're always going to optimize for the intermediate metric, even though it's like a classic thing. If you're doing an end-to-end optimization and didn't look at your vals until you finished RLHF, we would probably have different models. But that's not how engineering works.
There's 2 points to that. The first is like, annealing, it kind of works for the kind of benchmarks people focus on the most. But then there's a question of like, okay, are you actually just like collapsing the kind of task distribution of the model to the things you're kind of measuring, but maybe not the true distribution used by the community, right? And I think there's a second point, which I think is, maybe this is actually too much of a digression, but it's like, I think there's an interesting debate to be had about like, data quality is a kind of a bit of a misnomer, in the sense that like when we say data quality, we're actually saying, oh, this data mix works well in this benchmark, right? But if you take like a no free lunch like kind of theorem, you must be like hurting task performance somewhere, right? And
I think I'm like on record of like the alpaca eval hater. I say this all the time, because I think alpaca eval is sacrificing actual usefulness normally for alpaca eval. Like if you get a 1 to 2% bump on alpaca eval, great. But if you're getting like a 10 to 20 bump, like you're sacrificing the actual chat abilities. Like
Yeah,
we released some models trained with PPO, and our PPO models are not very good at instruction following because they like don't follow modifications like be concise or some stylistic things. And they're just so yappy. They just say so much, but they do well on scores, and especially PPO helped Alpaca Eval. So we had to figure out how to kind of corral that signal without just totally cooking it.
yeah. It's like a whole discussion like evals, I guess, but like, yeah.
We could come back to evals in a second. The last question that I have is like, there's multiple trends. Like Llama 3 downplayed the importance of like instruction fine tuning relative to RLHF. I think there's other quotes in this Latent Space podcast of talking about it. And I'm kind of wondering, and Nematron had this report where they report SFT and then multiple stages of RLHF. They use some DPO thing. The algorithm, I think DPO versus PPO is overblown, and that'll kind of be a wash eventually. DPO, like everyone knows DPO's advantages of being simpler, but like, are there certain capabilities that could kind of only come for RLHF, and people trying to do them with SFT are kind of wasting their time? I always thought safety was in this bucket, where it kind of makes sense that it's hard to train a model to refuse just with SFT, and these kind of preferences are like in terms of a latent, like, or like an inductive bias makes a lot of sense, or you prefer refusal over a super harmful thing that's not hard to see. But with like reasoning, are there certain sequencings where like SFT primes you and then RLHF could really help reasoning or code? Because this seems like what, if you think like parse OpenAI and stuff, where they're like really using PPO to help with reasoning and code, but how do we start to parse that and make kind of rules of thumb there?
Yeah, I think there's two ways to answer this. I think first, maybe the history of this, and maybe I can give some context on like the Llama side. And then maybe, more on something on the reasoning side. So the history is actually quite interesting. I would say, in early, when was it? 2023. My dates are wrong since the pandemic, but this was after ChatGPT. There was actually a debate, internally in Meta, and a lot of like senior people were actually very skeptical towards RL. Like I would say the view was,
it's not just at Meta. There's like we don't have to name names now, but you can see when different companies embraced RLHF.
Yeah,
if you like really start to look at their models.
The view like that was like RL was a dead end, and that even DeepMind was moving away from RL at the time. We should just do SFT and stuff. But at least the folks in the Galactica team that came into like the Llama team, we were like quite scarred by like hallucinations. They were like, no, we definitely need some like we need to have like the right objective. We need to make sure language models are kind of know what they don't know. And while maybe you can get some of that behavior through SFT, it seemed like that wasn't the best way to do it. So we were definitely like quite high on RL right from the beginning, and eventually I think the Llama 2 paper definitely showed that a lot of the the advances in kind of helpfulness and harmlessness were kind of via the RL stage. So I think that was fairly vindicated. On the reasoning side, I would just say it's simple. It's like comes back to like next token prediction not being the actual objective you want to achieve. The objective you want to achieve for reasoning is like, do you get the right answer or not? Especially so for reasoning, because it's a high precision task. If you get one token wrong, unless you have like backtracking integrated and stuff, like it's you're never going to recover. So that's why you want to integrate.
Backtrack token. That's a throwback. Sorry, the like backspace token. That was a random paper that is interesting that never scaled.
Yeah, all these kind of weird things. So it's kind of fairly natural that you'd want to have that in the model. But I think on your point, like there is a point at which these techniques kind of overlap, right? So if you're doing quote unquote SFT and rejection sample prompts, right, you're pretty much doing something close to PPO anyway. So and same for reasoning. Like if you maybe like sample the model and pick the ones that your verifier says correct, and then do SFT on that. If these things are sort of connected. And I think the final point is like, I would say the community like overreacts to like certain methods being used, and they think, this company used DPO because they must have found it's fundamentally better. But actually, it's usually due to either like practicality.
Yeah, that's what I think.
Right? You have a 503 B model, and you want to do PPO, and you want to have like a reward model evaluation. It's going to have a lot of memory considerations. It's not like it's
especially with DPO. I think with the 405B, I'm guessing you probably did the thing where you cache the reference model, so then you don't even need to have two I hadn't thought about this, but essentially with DPO, you could cache the log probabilities from the reference model, so you don't need to keep them in memory when you're doing the loss of the primary model. So like for DPO, you don't even need an extra copy of the model in memory, which therefore means like you could essentially use the same exact stack that you used for the trading. So you don't have to comment on this, but I think that's probably partially why Llama just used the DPO.
Yeah, I think people don't appreciate as well. It's like people assume the big companies, okay, they have so much compute, like tens of thousands of GPUs. Compute isn't a constraint, but all these things are subject to Say's law, right? If you have more compute, you're going to train a bigger model. And then you're going to hit the constraints. It's just like the whole thing of like, okay, trying to solve traffic by building like another lane, right? But then it's like, oh, you just created another lane, so I'm going to use that lane of traffic. So it's like, so I think practicality is a factor. And also just things like, okay, what is the researcher in charge, like kind of favorite method, these kind of things. And, sometimes like politics as well. So, and I think the community has made a mistake of over-optimizing it. There was a mixture of experts, like kind of like phase, right? I don't think there's like anything inherently better with either method, but they just have different trade-offs and depends what you're trying to achieve, right? So if you're trying to serve lots of people in inference, maybe you kind of want more of an MEOE approach. If you're just optimizing for like something simple and maybe easy to train, that's debatable. Then maybe you go dense, but like I don't think these things are clear cut. So I would encourage people to like not just copy things because they're in like a paper from a big lab, but just try things out yourself, know what the problem is you're trying to do for yourself.
Especially in the fullness of time. I think people don't have enough long-termness in their decision making. Like people are not trying to make decisions about what will be right in 10 years. They are trying to get a model out as soon as possible. So there are very few people with the incentives of trying to understand in the asymptote which method is better. Almost no one, like I might have that incentive because I'm a nerd and I have an audience that is okay with me writing 4 paragraphs around like esoteric nerdy topics. But like for all these companies, that is not a real incentive.
And the other point I'd make, maybe it's like a separate thing, but I think it's really important, is like, I made this mistake throughout my career of like focusing too much on novelty and complexity. So when my first job in sports betting, like kind of we were doing like kind of horse racing, football, that kind of stuff. And I always had the perception that like kind of the other like kind of, funds had like really advanced complex models, but usually it wasn't. And I think there's a tendency to, especially for the secret labs, to assume that like kind of good performance is due to some like secret, amazing method. But more often than not, it's just like kind of lots of like, things from different people combined into one model, lots of like simple things done well and like solid execution. And frankly, for big firms, like a lot of brute force too, right? Because, big companies are naturally slow. But once they find a way to like kind of mobilize resources, then they're very intimidating and hard to beat, right? So, and if you know that, like, what approach are you going to do? Are you going to prioritize novelty, or are you going to do brute force if you have like tens of thousands of GPUs? So, I would encourage people not to be too intimidated by like this perception that like the big labs are smarter. I don't think they are.
They're earlier. They might be, or some of them are earlier, but they're not necessarily smarter.
So I think. Yeah, obviously the constraints are different because of less compute, I would say, in the open. But like, you just got to be first principle thinking, but then also be empirical as well, and just follow what works.
Yeah, kind of following on this, there's a lot of discussion around what the processes for making a successful foundation model lab are starting to leak out. I think like Armin has been talking about a few things on Twitter with great visualizations around like de-risking pre-training based on like a flop efficiency. Do you have any comments on what makes a successful post-training team in project? Because I think like I've talked to John Schulman a couple times, like he's been the king, like he started all of this, and like OpenAI is still kind of looked at as being the leader in this space. I think they've like on Chatbot Arena, they've fully cracked what the common people like in the style. They started early. Like, are there different considerations for this kind of post-training side of things rather than the pre-training that we might hear more about?
Yeah, I mean, there's probably better people than me to answer. So in our team, originally, like Rob, my co-founder, like he was kind of managing the team, and then I would say Tom was also like, Shalom was doing a lot of the work, and then more recently, Rui, how he's kind of like flies under the radar a bit. He was like doing a lot of the work on that. So they're probably better placed to answer. But I think, because I was like doing a lot of the like some reasoning and agents and stuff on the side. But I think the key thing is like it's just like lots of iteration. Frankly, lots of hard work. Lots of making sure that at each round at RLHF you're not regressing in certain ways. I guess it's hard to put a finger on it, but it's just like
There's simple things. Like I'm trying to get people to talk to models more. So I'm trying to build like a good vibe test about internal culture. And it's like, how do you vibe test for culture or for reasoning? Because I'm guessing there's a lot of that, which is like, you just have to, I mean, I remember somebody at Anthropic told me this. It's like, there's still a lot of it where you just put your finger up to the wind and you're like, model good. And like, I'm sure that still is happening. And like, that's just a simple cultural thing of the team to be like, you can't trust all of your numbers.
But I think it maybe is this fundamental question, which is like, the history of like, no, I wasn't in the early days of FAIR. Like I came in 2019, but FAIR was always like a very bottom-up organization, which was like a great thing. That's why things like PyTorch emerged. But I think the real insight to why that maybe like OpenAI was like ahead, at least at the early stages, was like they had like more of a top-down culture, and just had like focused bets. Like they saw like the potential of LLMs early on, and it was a top-down prerogative of the company to focus on that. And in essence, like it was more an engineering problem than it was a research problem in a lot of ways. And seen that too. Like I think a lot of people were surprised that the Llama 3 paper wasn't as like kind of quote unquote novel as they were expecting. But that just reflects the fact that a lot of it is just engineering, and engineering is really hard and like a lot of hard work. Not always like a lot of new methods, but like it is like a lot of hard work.
We're starting our like next fine tuning model, and everyone's asking me like, what should we work on? I'm like, we just have to go filter data and generate more complete. Like we have a lot of prompts, we have to filter prompts, we have to generate completions from good models, and then we have to make more completions and keep doing this process. And in 10 weeks, we'll probably have a very good open model. And it's just like, we just to be boring for 10 weeks, and we have like 10 people involved. So it's a bit of a bigger project, which I think is the right way to do it. And it's like, we've started getting improvements on IFFL by copying Nemotron. We use some open math data sets, and the math scores are getting closer to Llama. It's like, if we had told you what we have done to get like these basic improvements, it is the simplest things ever. It's like browsing Hugging Face and being like, NVIDIA released some JSON format data and some instruction format data. Like we added in and the numbers go up. It's like,
I think it's a weird one, because I think I think I said it earlier, but it comes to an interesting question where this kind of approach of essentially just like grinding until like, I don't know, the open LLM leaderboard like numbers get to 100% or something. Like we're in this weird situation, I think, where we're going to get to a situation where all the benchmarks are solved, but then we haven't really, in my mind at least, solved intelligence, right? Like what does it mean that we'll get close to 100% on math, without any inference time search, at least not at inference time, maybe during the like creation of the synthetic data. But so I think sooner or later it looks like an exponential LLMs, but we're actually on an S curve, and eventually we're going to get back to this mode where we can have to do new things. And I think that's great, because at least that's what motivates me. But yeah, I think there's waves, and I think we're in this kind of heavy exploitation mode right now with LLMs, away from the kind of glory days of architecture kind of exploration. But my hope is at least that we'll get back to the stage where we kind of exhaust all the benchmarks, then we have to say, okay, now we need to do something completely different. But who knows? Maybe scaling.
I see it similarly. Like I still think we have a year or two, at least in the open. Like if the closed models start saturating and they start doing things differently, that's fine. But eventually it'll all get there. And in that phase, I mostly do this just to make sure that the like ecosystem doesn't fold in on itself, mostly through to like policy exposure. So that's probably like the one sentence summary of what I'm doing these days. Just like add transparency so that the regulatory capture doesn't like nuke everything, and that's fine. But I think it's still longer than people expect. I don't think we have true signs of saturation in terms of the top end. We'll see with GPT-5. If GPT-5 never comes out, then we really know. But it seems like it's going to come. I think there's enough signs that it'll come eventually. I think I don't know the answer to this, and it's not really our expertise, but I'm interested in the potential architecture of GPT-5. And if it's GPT-4o like, and they're using more multimodal data to try to keep the data engine going relative to just going bigger. And I don't know the answer, but that's kind of the future questions.
Yeah. I mean, at least in my mind, like 3 years ago, the thing on the horizon I saw was kind of like agents. And I think that's where, frankly, a lot of people are working right now. This like kind of more long form task when an agent doesn't have to answer a question, it can go away, for a while doing some research and come back for an answer. And I think that will, frankly, just take up a lot of time in the next like 5 years. It's both like I think a compute problem of like bigger models, more scale will do better. But then I think it's also an interesting data problem of like, how do you like generate these trajectories? How do you get reliability? So it's not like it's more successful, more steps. And I think it seems in principle it's solvable, but I just think it will take some time.
Yeah, it seems so engineering required. Like it's not like it doesn't seem like something that's just going to emerge. It's like building a whole system and scaffolding around agents is mostly what I think. Just unglorious.
Yeah.
Okay. Anything else you want to add? Do you want to get people excited about your startup, or is it too early?
Maybe too early, yeah.
I
mean, what I would say
time.
Yeah. I mean, it's been nice to like, kind of take a step back for a bit and like, try and look a bit ahead into the future. And for me, like, my best days creatively were always like my teenage years when I get back home from school and like do programming and stuff. And it's quite nice to feel like to be in that zone again where I can just like shut things off and do some work. But yeah, I think broadly, maybe just to give a hint of the areas I'm interested in, I think coming back to it is this question of like, for me, like alignment is going to be a question of like, how do you make kind of AI more human-like? Like how do you, even things like, deception, which Anthropic have done like lots of really good work on, it's essentially a question of like, you're saying that the latents of the AI are kind of misaligned with like humans. But the question is like, what are the latency of humans anyway? Like how do you generate these things? I mean, this is very abstract and high level, but I think that for me is the kind of fundamental question I want to work on. But I think I can talk about it later in the year.
Yeah, sounds good. Thanks for coming on. This was great. I think people are going to get a ton out of this. I think it's just a very sensible conversation on fine-tuning, reasoning, and some of the things that got us here. And it's kind of what I was hoping out of it. So thanks again.
Yeah, great to talk, Nathan. Yeah, have a good one.